So today we're continuing our talk from 8.2 on square root properties, and we're just going to pick up where we left off. And I was thinking about a better way to explain these problems, a little bit better way of writing it. So this number right here we're saying is irrational because it's not a perfect square. So we're trying to figure out it's in between what two perfect squares. It's just itself, the square root of 84 is in between the square root of 100, because that's the next perfect square greater than it, and the square root of 81, which is the square root with the perfect square below it. So that means that the square root of 84 is in between 10 and 9. So here it's saying 9 is less than the square root of 84. Square root of 84 is less than 10. As soon as I put a negative sign on it, though, it basically is the opposite, just the opposite sign. So since the smaller number would be negative 10 and the bigger number would be negative 9, that it's in between. Here, let's just start with the square root of 3. What perfect squares is it in between? 1 and 4, right? Square root of 1, square root of 4. These are the perfect squares around it. Well, so the perfect square is 4. The square root of 4 is 2. Yes, 2. I don't know why I put a plus in front of it. It's positive. Okay. All right. Now I know why I put I know why I put a plus. It's because I was getting ready for this. If I add 2 to the square root of 3, I'm going to add 2 to each one. So I have 3 is less than 2 plus the square root of 3, which is less than 4. So that looks a lot better than what I was writing before. It was all scribbly scrabbly. So let's do this one. Let's start with the perfect square. So let's start with the square root. Sorry, square root of 20 is not a perfect square. What two perfect squares is it in between? Yes, so 4 and 5. Let's just take it from 16 and 25. So that's where we're getting the 4 and the 5 from, those perfect squares. Now, if I am going to divide all of these into 3, essentially the numerator is 3. 3/4 is less than 3 divided by the square root of 20, which is less than 3 divided by 5. So that problem looks like that. So that's what it means by a 3-part inequality. 1, 2, 3. Okay, let's go on to the next page. For any positive real number x and y, we have the following properties. So the multiplication property of square roots and the division property of square roots. And basically what this is just saying is, if I multiply two perfect squares together, it's the same thing, you know, each under their own radical and together. So actually we're going to demonstrate each of the properties using 4 and 9. So our x will equal 4 and our y will equal 9. So if we take the square root of 4 and we multiply it by the square root of 9, we would get 2 times 3, which is 6, right? Did I do that right? Versus if we take that 4 and 9 and multiply them together under the same radical, we're going to get the square root of 36, which is also equal to 6. Okay? That's the multiplication property. For the division property, we have the square root of 4 divided by the square root of 9. That would give us 2 over 3. Or if we take the square root of 4 over 9, that's also going to give us, oops, not the square root anymore, that's also going to equal 2 over 3. So we can see that with multiplication and division, we can separate those radicals or we can combine them together. We know that this is not true of addition, right? Remember when we said this is not to be confused with addition or subtraction. If you have the square root of x minus the square root of y, it's not going to equal the square root of x minus y. Okay, so or plus. Doesn't actually matter if it's subtraction or addition. And we saw that in a few examples. So the square root of 4 plus the square root of 9 would be 2 plus 3, which is 5. And watch, that's not going to be equal to if we take 4 plus 9, which is what? 13. The square root of 13 is in between. You can tell that it's less than 4, right? Square root of 13, if we take that on our calculator, we see that it's not the same thing as 5. Square root of 13 not equal to 5, approximately 3.6. And then we know this is an irrational number. That's why the decimal goes on for infinity, does not repeat. So realize that the only properties that this works for is going to be multiplication and division. Well, why do we even need to know this? We do this because we want to simplify square roots. And we're doing that using the multiplication property. So what we're going to do is we're going to look at this number. The square root of 50, we know 50 is not a perfect square. Do we all agree about that? So it'd be irrational. But there are factors of 50. 50, give me two numbers that multiply to 50 and make one of them a perfect square. 25. 25 times 2. So that means we can separate this into 25 times 2, and that's the same thing as the square root of 25 times the square root of 2. Well, I know that I can take the square root of 25. What is the square root of 25? 5. So 5 times the square root of 2. And we write it like this. It almost looks like a coefficient with a variable, but it's just the radical at the end. Now, this is the same thing as the square root of 2. Square root of 2 times 5. But do you see how it's harder to tell if the 5 is underneath the radical or not? So that's why we put the number in front, just like we do with variables. Okay, do you want to see one more before you try it? Now, if you see a number and it's so big that you can't tell right away, I would you could do a couple of different things. You could start dividing it by perfect squares, or you could even do the prime factorization. So let's look at the prime factorization of 60. Give me any two numbers that multiply together to give me 60. 5 times 12, okay? And then let's keep, this is prime, so that stays. 12 breaks down into, yes, 4 times 3. 3 is prime. 4 we know is a perfect square because it ends up being a number times itself. So right here is your perfect square. So we can break down the square root of 60 into the square root of 4 times 15. Now, why did I go ahead and multiply the 3 and the 5 together to give me 15? I mean, I could write 5 times 3. It's because 15 has only factors of 5 and 3, so there's no perfect squares inside 15, so it's going to stay in the radical, right? If I simplify this further, I have the square root of 4 times the square root of 15. Since the square root of 4 is a perfect square, what is the square root of 4? 2. So this becomes a 2. The square root of 15 has to stay inside because it's not a perfect square. Now, if you're doing these problems and you're not sure if you're getting them right, on the regular test, you'll probably need to do part of these with no calculator. But just because we want to make sure and check right now, what I'm going to have you do to check is you can take the square root of 50 and you will get a decimal. 7 point, that's kind of like what we were doing on the last page. Square root of 50 is in between 7 and 8, right? And then you can actually also do 5 times the square root of 2. And did you notice that that was the exact same decimal point answer that I got when I did the square root of 50? Don't believe me? Go back. Enter. Okay, one more. Oh, now it's not going to save the other one. But what I'm saying is once you have your simplified answer, now you want to always look, this is the answer that we're going for with the number in front. Even though this is equivalent, we don't really want to use this format. So here, if we look at the number inside and make sure that there are no more perfect squares that can come out. So do we kind of understand this process? Do you guys want to try a few problems here? Or do you want me to show you any more? Do you need one more example? Yes? Yes. You're going to use all the perfect squares. So can you give me an example? Is there one problem in particular that you're thinking of? $36, that was kind of like this example, the square root of 36, right? It does have 4 and 9 are perfect squares, but 36 is also a perfect square. So actually, if you multiply two perfect squares together, you actually get another perfect square. Ah, yes. Okay, well, why don't we just, since we have this one with the negative here, actually, I'll just go to here, negative square root of 360, because there's probably a lot of factors of 360. But can you see a perfect square right away that's in there? Which one? 36 times 10. Okay, so I was going to factor it, but 36 times 10 is perfect because, well, that's a perfect square, but also 10 is 5 times 2, and there's no perfect squares in there. You know, 5 and 2 are both prime. So this is the same thing as the square root of 36 times the square root of 10, and we just have that negative out in front. So what's our final answer going to be, most simplified? 6 radical 10. Okay, you guys try the rest and we'll share out in just a moment.